Me llamo Sarah y soy una evangelista y productora de XR and Unity. And that's about all the Spanish I can speak, so I'm going to do the rest of this presentation in English. So if you have any questions or it wasn't clear what I said, I will be around for the rest of the day, so you can come find me, and I'll try to speak slowly for those of you who are learning English. I can guarantee that your Spanish, or your English, is better than my Spanish. So today, one thing I do know about, that's not maybe Spanish, I do know a lot about developing VR. So I'm going to talk to you all about developing high-end VR. And we're going to start by going over some examples and different platforms. I'm also going to talk about how you can integrate with controllers, inputs, interactions. I'm going to go over some optimizations and best practices for VR. We're going to talk about the different stereo rendering methods. There's 3, and it's very confusing, so I hope to erase that confusion today. We're going to talk about immersive audio, or spatialized audio. And if we have time, I'm going to show you how to use inverse kinematics to create more presence in your games. So I first want to start with this awesome fact here that actually 70% of VR experiences and games are made with Unity. I think that's really awesome. Here is a short video that'll show you some of these games. Let's see if we can get there. Oh. Do we have audio? Let me get audio going. Headphones, speakers. That's the projector. Speakers. Headphones. That's for the Rift. Okay, let's try it. No. All right, I'll just blast it from my computer. All right. So those are just a few examples. There's a lot more games that are coming out every day. Here are some of my personal favorites. All of these you can get right now on the Steam store or the Oculus store, except for Life of Us in the bottom left corner. That's coming out soon. So I won't spend too much time on this because you guys can all play these. If you have a Vive or an Oculus, we have some of these games downstairs as well. So I want to talk about what high-end VR means, because there's basically 2 main ways you can develop for VR. There's mobile VR, which is going to be on a smartphone, and then there's high-end VR, which you're going to have 6 degrees of freedom. You're going to have room-scale tracking, so you're actually able to walk around and move your arms around. So it's very different from mobile VR, where you're limited to just looking around. And because you're running this on either a PC or a high-end console like a PlayStation, you're able to get much higher graphical fidelity. Of course, you also have to run at a higher frame rate, which comes with its own challenges, but we'll get into that. And you're going to get more audio capabilities. So I'm not saying that high-end VR is better, but it might be a little better. Here are the three main hardware platforms for high-end VR. PlayStation VR, HTC Vive, and Oculus Rift. I'm going to be demoing on an Oculus Rift today. And then there's also a bunch of Windows mixed reality headsets that came out earlier this year. And these are actually a handful of different headsets that all work on Windows 10 and all use the same SDK that's built into Unity. So you can build to Microsoft mixed reality using any of these headsets. And these headsets are actually a little bit more affordable than some of the other options. So I'm sure we're going to be seeing a lot of them coming out soon. And good news, Unity gives you native support for all of these platforms. So if you want to start developing for any of these, you can do it in Unity today without downloading any extra SDKs. So that's very exciting. And there are a lot of benefits of using the native support built in Unity. Of course, there are third-party SDKs or plugins, but we actually have all of these SDKs built into Unity. And having this native support means that when we push out a new release, so for example, we're releasing 2017.3 next month, you know on day one of that release, you're still going to get support for all of the platforms, whereas some of the other plugins, it might take them a little bit longer to catch up. And then you're also going to have a single API for all of these headsets and controllers. One of our newest features that I'm really excited to show you all is called the tracked pose driver. And this is a component that's built into Unity now. It's shipped with 2017.2. And this allows you to just basically add a component. You don't have to write any code. Click a couple buttons. I mean, that's the most tedious part. You have to like click 2 buttons. And then you automatically get tracking for controllers, whether it be for the Oculus, for the Vive, for the Windows mixed reality controllers. You can also use this to get tracking for AR cameras, which are also known as smartphones these days. So you can use it to get tracking for anything that is supported as an XR device in Unity. So let's jump into Unity, and I can show you how it works. All right. So I have a project here open. Right now, all I have is an environment. Whoops, and I scrolled way too far out. And then I have this player rig down here. So my player rig is where my VR player is going to live. And underneath that, I have a right hand, and that has a sword attached to it, a pretty cool sword. It actually is Unity branded, which I like. So you can see the logo on the sword. That's pretty cool. The left hand has the sword as well. And then we have the HMD, which is our camera. So I already have VR enabled. Now, if I hit play, I'm going to get tracking to my headset automatically. This is automatic in Unity. When you have VR enabled, you're going to get tracking in your headset. And to enable VR, all you need to do is go File, whoops, Build Settings, Player Settings, and then there's this new setting called XR Settings. And you'll just check that box, Virtual Reality Supported. And then when you add a camera, your camera will automatically be taken over by your headset. Now we do have a couple steps to get these tracking, which I'll show you right now. So I'm going to go to my player rig here and select my right hand, which is where my sword is. And you can see that up there, my right hand. And now I'm just going to add a component. And I'm going to type tracked pose driver. And again, this is built into Unity. You don't have to do anything to add this. It's built into 2017.2. And I have these different options. I have a device option. I'm going to go with XR controller. And I'm on my right hand, so I'm just going to select right controller. And I want my tracking type to track its rotation and position. You might want it to just be rotation, just be position. It depends on the design of your game. And I want it to update, I want it to update the position on update and before every render, because this will give me the smoothest tracking. If you, for some reason, don't need your tracking to be perfectly smooth, you might just have it update before every render or on the update function. All right, so now I'm going to do the same thing for the left hand here. XR controller, left controller. All right, that looks good. So let's see. All right. And I have my swords tracking. So that's pretty cool because all of that is built into Unity. You don't have to download any extra SDKs. You don't have to write any code. And you already have head and hands in VR. We're really excited about this feature. All right. OK, so that's great for tracking. We have tracking. But we can't really do much with just tracking. Yeah, we can use our swords to fight. But we really need inputs to get interaction in VR. And don't worry, because we have built-in support for that too. And this is probably the best GIF that I've ever found in my life, like a guy dancing around in VR. I'm probably going to use this in every presentation I do for the rest of my life. All right, so here are the controllers that have native mappings in Unity. So we have the Windows 10 controllers, or the Windows Mixed Reality controllers. And these are the controllers that you can use for any of those Windows Mixed Reality headsets. It's going to be those same controllers. There are the Vive controllers. If you haven't seen those yet, you can check them out downstairs. And then the Oculus Touch controllers, which I'm using here today. So I'm just going to quickly go through these different controllers and the types of inputs you get and how they map to Unity. All of this is in our manual, so don't feel the need to take photos or anything. You can find it all online. So let's start with the Vive. You've got a few buttons here. You've got a trackpad, a trigger button, a grip button, and then they directly map to Unity button IDs like so. So our menu button is going to be Unity button ID 2 on the left hand and 0 on the right hand, etc. You can get the idea from looking at the image. We also get Unity axis IDs from the trackpad and the grip button. So you're determining your horizontal and vertical axis on your trackpad. And then on your grip, you can get a number between 0 and 1 of how much are they gripping. And then the Oculus Touch has quite a few buttons, as you can see. And all of these directly map to Unity buttons as well. Here's some of the mappings for the buttons. You're going to get some different press buttons. And then for some of them, you're just going to get a touch. So you don't actually need to press the button. But if you touch it, it'll sense that as well. So that's pretty cool. You can do a lot with that as a developer. And then you're going to get access IDs as well for the thumbstick, which I can just move like a regular joystick. And then then we have like a trigger. So the trigger you can hold anywhere from 0 to 1 and determine how hard they're gripping. And then we have the Windows MR inputs. And these are pretty brand new controllers. So all of the information for these are going to be actually on the Microsoft developer website. But they have all the mappings available there. So with the Windows controllers, you actually get a thumbstick and a trackpad. So you can do pretty much everything you can imagine with these, which is exciting. Here's some of the buttons. And I forgot the slide for the access IDs. But you do have access IDs as well. And this is just an image that I took directly from the manual, the Unity manual online. And it shows you how the buttons match up between the Vive and the Oculus Touch. So you can get this by just going to the Unity manual. All right, so now that we know that we can get our inputs in VR, we want to set up some interactions. And one thing that I want to point out is that most of the time when you have a user that goes into VR, if they see something that they can reach, they are going to want to pick it up, like 99% of the time. And it's so disappointing as a player of a game when you want to do something and you reach and you're like, oh, I can't pick it up. And it just breaks the immersion. So you really need to think about when you're designing your games, everything that's in the user's space that they can reach, they should be able to pick up and interact with. So you're going to need all sorts of interactions for VR that you don't need in traditional gaming. You need to think about picking up and releasing objects. In regular games, it's not as important that they can pick up every single object. But when you're in VR, it's just natural instinct. You want to like pick stuff up and throw it around. I like personally love making messes in VR because I don't have to clean it up, whereas I do in real life. You're also going to need to think about locomotion techniques. How are you going to get movers around? A lot of people use teleportation for this. And then you need to think about how are you going to let your users interact with your UI. And one thing that I want to point out too is make use of haptics. That haptic feedback really makes it real if a user picks up something heavy and they can feel it in their hand with a little bit of haptic feedback. All right, so let me give you guys a short demo on how to actually create some of this interaction. So I have a very similar scene here. The only difference is I have a menu up here. So all I'm trying to do is get my user to hit that play button. Now, because we're not in VR, our regular Unity events like on over, on click, all of that aren't going to be automatically enabled. So I added this script here to my right hand, and my left hand. And this is a raycast input script. So what this script does is it allows you to shoot a raycast out of your controller, and that raycast will interact with your UI. So you can use this for interacting with just traditional canvas UI, or maybe you want to give your users the ability to reach objects that are out of their reach, like they can just extend their arm a little bit. And these scripts are not by default included in Unity, but I have them posted up on GitHub, and I will give you all the link to that at the end, so you can download these scripts and start using them today. And let's take a look at what that looks like. So I have, you can see that I have these raycasts shooting out, and when I go over the play button, just like if I were running over it with a mouse, my highlight will activate, and I can click a button to start the game now that I've interfered with that. Ooh. Putting on a VR headset with glasses is always a little challenging. Some of you probably know this. All right, and if you are just getting started and maybe you want to play around with some prototyping, you have like a great idea for VR, but you don't want to write all the scripts to do the interaction, there are a bunch of interaction toolkits available that are completely free for developers, and you can use these to have interaction with objects, gaze-based interactions, locomotion. A lot of people use VRTK. It's available in the Unity Asset Store. It's also available on GitHub. That'll work for the Vive and the Rift. Steam VR will also work for the Vive and the Rift. And then Oculus made a toolkit specifically for the Rift, and that gives you really cool like blue shiny avatars for your hands and all sorts of things that would probably take you as a developer a long time to make, so they made it for you. And then if you're planning on using the Microsoft Mixed Reality headsets, then there's a Mixed Reality toolkit available by Microsoft. So you can actually use that toolkit for both the headsets that are virtual reality and the HoloLens. So that toolkit will give you help with both. And again, you don't need these to develop VR in Unity, but they are helpful third-party plugins. Like I mentioned before, we can't guarantee that these will be updated with every release of Unity, but most of them do a pretty good job of keeping up, and they are really good for prototyping. All right, so now I want to get into some best practices and optimizations for VR, and this is a pretty challenging, right? So, as I mentioned, we do get that really high graphical quality with desktop VR. But that's also because we're producing content that's running at 90 frames per second, and that's hard to achieve. It's a lot higher than traditional gaming. So I'm going to go through some ideas for how you can help your game perform and also make your game more usable for the user. So the first is, of course, design for performance. A lot of developers come to me and they're like, oh, I have this really great game that I built for PC or for Xbox, and I just want to like put it into VR. And that's really challenging to do. A lot of the time when you're designing a VR experience, you need to design it with the intent that it's going to be a VR experience, because there's all sorts of challenges for VR that are different from traditional gaming, and different game in the environments too. It's hard to take an environment that wasn't built for VR and put it into VR. Like, you really need to think from the beginning, how can I make this perform well in VR? And also check your frame rate often and use the profiler. So since you are going to be building to achieve that frame rate, it is really important that you check your frame rate. Also, it's really important that you're constantly checking how your game looks in VR. It is a little bit of a pain to have to put your headset on, change something, take it off, like back and forth. But it's worth it, because you're going to find something that's not working so much quicker if you're constantly iterating by checking how it looks in VR, checking the performance, your frame rate. If your frame rate's not perfect, use the Unity profiler and try to figure out what's stopping your frame rate from being what you want it to be. And then, of course, you want to optimize your textures, geometry, and lighting wherever possible. And I'm going to go through some tips on how to do this in a bit. And also, you want to use forward rendering for VR and multi-sampling anti-aliasing, which is only enabled through forward rendering. All right, so let's talk about designing for performance and what that means, because it could mean a lot of things. Here's what I think it means. You want to actually think about your experience design. So I don't know if some of you saw me, maybe at the beginning, I had to get my sensors all set up, and it took a few minutes. They had to be like perfectly in place. And even then, since I'm using the Oculus, I only have like 180 degrees that like I can actually move around with. So you really need to think about this when you're designing your experience. Is your user going to be using an Oculus potentially? Are they only going to be using room scale like the HTC Vive? You don't have all the answers to this, so it's always best to design for what you might think could be the worst case scenario, say 180 degrees. I don't know if any of you guys have heard of Alchemy Labs. They made a game called Job Simulator. Have any of you heard of that? And Rick and Morty, virtual reality. They actually designed their second release of Rick and Morty. They had different levels for each scenario. So they had, it was all the same environment, but they reconfigured it. They had like 4 different scenarios. They had 180 degrees standing. They had 360 degree standing. They had 180 degree room scale. So they had like 4 different environments. That's one approach. It worked well for them. Maybe you're just one developer and you can't do all of that. So in your case, you might want to design for the 180 degree just in case. As a VR player, when you have to look behind you and suddenly your controllers lose tracking, it's no fun. So really think about your experience design and how you can optimize that for VR specifically. And then you also want to settle on a very focused experience. So think about the play area and how, like, the places that your users are in. You want them to be really focused on what they're doing. It's really easy to want to create these giant landscapes and huge environments in VR. And, you can really lose your focus very quickly. And you really want to focus on what that exact level or that scenario is trying to achieve, and build your levels and your environments around those scenarios. Of course, you'll need to do extensive prototyping for this. And again, environments should be small and highly quantized. So think about the fact that your user is going to want to reach out and touch everything. So you might want to actually design your spaces so that they can do that. And that's really going to, not only is it going to make it a better user experience, but if your spaces are smaller and you have less going on, that's also going to optimize the performance of your game because it's not rendering as much. So you get, a lot of pluses from that. All right, so let's talk a little bit about texture optimization. High resolution textures are going to be very expensive, so you want to try to minimize the use of these. One method that you can use is using multi-materials or detail maps. So you can have multi-materials set up on an object so that when your user is farther away, you're actually rendering the lower resolution texture. But as they get closer, you start to render that higher resolution texture. Your user is not going to notice the difference, but your performance definitely will. You can also test lowering the resolution of specific maps like your ambient occlusion, your normal maps, and your metal and smoothness. Just always play around with lowering the resolution of different settings there. And you can use Atlas textures to combine all your textures into one sprite sheet, and then Unity will only view it as one texture, and it'll be less work for your CPU. All right, now geometry. This is also very important to VR. One thing that I think is really important is authoring your assets with context. When you're going and you're creating your assets and your models, as you're creating them, you really need to think about the environment. How far away is your user going to be from this? Does it matter if it's super high quality? If you don't need a really high quality model with tons of geometry, then don't use it. That's just a waste of your performance. Now think about something like your user's hands. They're always going to be looking at their hands. So this is something that you might want to spend a little bit more time creating a really high quality model there. And you want to be constantly considering and testing occlusion in your environments. Again, the viewing distance. As you're creating your geometry, think about how far is it going to be? And you can use level of detail groups. You can use multi-materials to optimize your specific models for how far away your user is from them. And there we go, using level of detail groups. You also want to use Unity's batching system. So Unity has a dynamic and a static batching system. The dynamic batching system is going to be enabled by default for all of your models that have the same material. So if you can get as many of your models using the same material as possible, even if they're using different textures, then Unity's dynamic batching system is going to process them a lot faster. For static batching, you actually need to mark your objects as static, so these are objects that aren't going to be moving. So here's an example of a stone tablet, and it has a ton of complex geometry, but we were able to get it to render and look really nice up close using just normal maps there. So it's actually not a super complex model. And then I also want to talk about level of detail groups here. So you can see on the left, we have the lowest level of detail, and on the right, we have the highest level of detail. And we just are using these 4 dogs in 3 rows. And as it gets back to the furthest row, it's nearly impossible to figure out which one is the high detail and which one is the low detail. So you can make use of level of detail groups. This is a built-in feature in Unity to determine what level of detail you should be rendering based on your user's distance. All right, and lighting optimization. Lighting is obviously pretty important to most games. It's very important to VR, but you want to be optimized. So we encourage people to try to use, if they can, limit yourselves to 1 dynamic shadow casting light and 2 secondary lights. Other than that, try to bake as much of your lighting and use light probes. Really try to avoid point lights if you can. These typically don't work well in VR. And remember, not all of your lights have to be real time. If you stick to that kind of high level rule of 1 shadow casting light and 2 secondary lights, you should have pretty good performance there. And of course, you can also use lighting layers to determine, which object should be affected by which lighting, and this is also going to optimize your lighting. All right, now I want to get into something that has always been, a little bit of a challenge for me to understand the difference between these stereo rendering methods, because there's 3. There's multi-pass, there's single pass, and there's single pass instancing. And these are all different rendering methods for VR. And up until recently, I hadn't seen a clear explanation of the differences between the 3. So even I was like, single pass instancing, is that just like a better version of single pass? So I'm going to explain to you all what the difference is right now. Yeah, this was me a few weeks ago until I saw this amazing explanation of it done. So for this explanation, I'm going to be referring to this scene here. It's just a red cube and a green sphere. And let's start with multipass. So when we're actually rendering, we're creating two viewports, one for the left eye right here, and then we're going to draw the cube for the left eye, and then we're going to draw the sphere for the right eye. And then we're going to go back up to the top of our scene graph. We're going to create another viewport texture for the right eye. We're going to go through our scene graph again. We're going to draw that cube, and then we're going to draw the sphere. So that's why it's called multipass. We're actually going through our scene graph multiple times. Now, earlier we introduced single pass for PC and PS4. And what this uses is actually a double wide texture for the right and the left viewport. So you're going to have, you're going to create the viewport for the left and the right eye, draw the cube for the left eye, then hop over to the right eye and draw the cube again. Staying on the right eye, we're going to draw the sphere, and then we're going to hop back over to the left eye and draw the sphere. So that's a little bit more efficient. We're still drawing everything twice, but we're only actually going through our scene graph once. And now stereo instancing. And this is, can also be referred to as single pass instancing. And this is a brand new feature that was just released in 2017.2. All right, so when we're going through this, we're going to start with both textures for the right and left eye at once. That's why it's called, you're doing an instance draw there. And then we're going to go through our scene graph, and we're going to do an instance draw where we draw both the cube and the right and the left eye at the same time, and then we're going to draw the sphere at the right and the left eye at the same time. So we're doing the same amount of work, but in a lot less steps, so this is a lot more efficient. The only caveat to this is that you do have to be using Windows 10 and DirectX 11 to be able to do this. If you build it using this method and then one of your players doesn't have those graphics settings, Unity will automatically just revert to multipass for you, so you don't have to worry about that. We are also planning to introduce a scriptable render pipeline next year, and we're specifically making one for XR. So scriptable render pipeline allows you, the developer, to customize your render method. And with that, we're actually going to introduce 2 default render loops. So if you want to use these, you can use them without any programming, or you can take them and you can modify them for your games. And those 2 are going to be a light forward rendering pipeline, and that's going to be aimed towards low-end hardware like mobile VR. And then there's going to be a high-definition, physically based rendering pipeline for the high-end PC VR. So I can't comment on the exact date, but look out for them sometime next year. All right, and I also want to go over some of the included SDKs for spatialized audio. So what spatialized audio does is it allows you to get sound from every direction. So, not just left or right, but actually above you, below you, where it's coming from. And your headphones will simulate where it is in the room. And this is really effective for VR, because a lot of times the way that you get people's attention is you're like, hey, look over here, with sound, and then everyone looks. So you can use sound to get people to look and interact where you want them to interact. And we currently have 2 spatializers built into Unity. We have the Oculus spatializer and the Microsoft spatializer. Now, Google also recently introduced what they're calling resonance audio, which is spatialized audio, but also simulates how those sound waves are going to interact with human ears, and also how they're bouncing off of objects in the room. So this is really cool. You can currently get it as a plugin for Unity, and in 2017.3, it will be built into Unity. All right, so we have a couple more minutes here, so I'm going to quickly go over inverse kinematics. What inverse kinematics does is it allows you to solve for a position on a robot or a humanoid avatar based on the movement of another part of their body. So if I'm moving my hand, inverse kinematics will figure out where my elbow needs to be. This is pretty much how all of robotics works. And this allows you to give your players realistic body movement and animation. It's really great for social VR. So if you're going to have experiences where there's multiple people in there, it gives the player a lot more presence when they can look at their friend in VR and actually see their body moving around. It's not always necessary for single player, because in single player VR experiences, you mostly care about your hands, but there might be a scenario where your player is like looking in a mirror and dressing up their avatar or something like that, and you want to be using inverse kinematics there. So you can use inverse kinematics built into Unity by using Mechanim and actually scripting the inverse kinematics method. But I'm going to show you guys a premium asset on the asset store called Final IK, and this does all of that for you. So I really like it. So I actually have, just like before, I have my player rig here, and then I have this, this avatar that I added, and it's just a simple blue man. Now, I downloaded Final IK from the asset store, and I added my VR IK script onto my man, and I'm matching up all of my skeleton parts from the hips all the way down. Let's see if we can lock this here, so you can see it goes all the way through the skeleton there. So now, it might look kind of weird because my arms are way over here, but you can see that my whole body is moving. You can even see my feet moving. When I bend down, you actually see my feet bend down. So it's a lot of fun, and it builds a lot more presence in VR. All right. And this asset, it does cost money. It's not free, but it's a part of our VR Essentials pack, which is a promotion that we're doing. If you're thinking about getting Unity Plus or Unity Pro, you get this entire Essentials pack for free with your upgraded. So that'll include the Final IK asset that I just showed you. It'll include a curved UI and a VR panorama renderer, so you can actually render 360 video out from your Unity scene. So if you're thinking about upgrading to Plus or Pro, here's a good reason to do it. And that's the end of my presentation. Here is the link to the VR scripts that I talked about if you want to get a photo of that, or if you don't have a chance, I'll probably post it on Twitter later. And that's it. If you want to get in touch with me with any questions, you can email me, tweet me, or connect with me on Unity Connect. Thank you.